Hi guys. So this video lecture is going to be just a quick chat about cladograms and how to read them and what they look like. So that way this will hopefully help you with your assignment for tomorrow. So I'm going to share my screen. And we're just going to look at an example of a cladogram. So here we see one. This shape down here is stereotypically what they look like, kind of like a V with a bunch of little lines going through the middle of it. So this vocabulary term that we see here, cladistics, is the method that classifies organisms according to what they diverged according to the order that they diverged from a common ancestor. So what that means is down at the bottom where the V meets, down at the point, that's going to be the common ancestor for all of these organisms. So as we go up that cladogram, we are going to see where the different organisms branch off. Typically, we see these descriptive words here on the side. So this word at the bottom, hair, that means we started off with a common ancestor down here. And the turtles are outgroup over here. Then we developed hair. This organism developed hair. So now we branch off, and the rest of these organisms should have hair. Okay, so we know that a horse has hair, a wolf has hair, a leopard has hair, and a cat has hair. Then as we go up, we become carnivorous. A horse is not carnivorous, so it's going to branch off right there. But a wolf, a leopard, and a cat are. Okay? Then we have retractable claws. A wolf is carnivorous and it has hair, but it does not have retractable claws, so it branches off. The leopard and the cat are what we have left. The ability to purr, the cat can do that, the leopard cannot. So the leopard branches off, and then we're left with a cat. So what this means is all of these organisms, if we go down that cladogram, all have a common ancestor very, very far back in the past. All right, so a cladogram, this is a branching diagram like what we just looked at, and it represents the phylogeny, which means evolutionary history of a species. Okay, so we're looking at these derived characteristics. We're looking at how these organisms are related, and so we can represent that using a cladogram. Okay, so here's just another example of one. So I'll kind of talk through this one with you because for your assignment for tomorrow, you're actually going to create a cladogram. So I want you to really understand how to read these. And they're pretty simple and they're kind of fun to look at. So down here at the bottom, we start, our common ancestor is a vertebrae. Okay, so think of a vertebrae, think spine. Okay, so we have a spine, we have those vertebrae in our back, right? So all of these organisms here, they have vertebrae, right? So they are vertebrates. Then we see this first branch here is our shark, okay? The thing that makes the shark branch off is because it is a vertebrate, but it does not have a bony skeleton. We know that sharks have that cartilage instead of bone. So they branch off. They do not have the bony skeleton. So from here, the rest of these organisms should be vertebrates and have a bony skeleton. The next branch off we see is that ray-finned fish. We know that it's bony and it's got a vertebrae, but it does not have the 4 limbs, so it branches off there. The other organisms should all have 4 limbs. So the next one up is the amphibians. So like some type of frog, right? So we see that it has 4 limbs, a bony skeleton, and it's got a vertebrae, but it does not have amniotic eggs, okay? So from here on up, we see another branch kind of going, another mini V here. So on one side of that V, we've got organisms that do all of these things. They're vertebrates. They've got bony skeletons. They've got 4 limbs, amniotic eggs. And these two have hair, right? Primates and rodents and rabbits. Those have hair on them. The other side does not have hair. They have eggs with shells as opposed to the hair. So up here, we're going to branch into crocodiles and birds. So this is just a really cool way to see kind of how these species are connected in a way, how they are related, how some of their structures are similar, how they're different, and where they differ. So this is just a really cool way to assess that and look at that. So kind of the difference between a cladogram and a phylogenetic tree. A phylogenetic tree is just a little bit different. So for a phylogenetic tree, the branches on the tree are proportional to the amount of change that's happened over time. So with the cladogram, we see the way that the organisms differ and the structure that we identify as being different. With the phylogenetic tree, we assess the changes that happen over a period of time. So we really use time, that's a factor in the phylogenetic tree. So this tree describes an evolutionary history by showing how the ancestors are related to their descendants. And that key point is that part that I have underlined there, and how much those descendants have changed over time. So time is a key factor in the phylogenetic tree as opposed to the cladogram. So we're going to look at them side by side. So on the left here, we see the cladogram, and we see this is where those words might be that tell us how they're different, right? But we see that these structures, or these organisms, all have similar structures, but they are all slightly different, right? And they've got those defining characteristics that make them different. But we don't really know, based on this cladogram, how much time has passed. The phylogenetic tree is showing us how they're different, where their common ancestors are, but this line over here is kind of our measure of how much time has passed. So typically when you look at one of those, they will be, this line over here will be labeled with some dates, so that way you can assess how far apart these changes are happening. The cladogram is kind of, the phylogenetic tree is the primary way that we use to look at this. The cladogram is a newer diagram that we kind of have started using, so they're becoming more popular, but we still use both. And then this is the last slide for today. This is just showing you kind of how to read the phylogenetic tree. So we already talked about how to read the cladogram. So this would be the phylogenetic tree. So we see they're going to be more of this box shaped as opposed to the V with the branches. They're going to be the box shape, kind of like a field goalpost for football. So where the two lines meet each other, that line going down, that's going to be the ancestor. The part where they branch away from each other is going to be that speciation event. So we remember from the previous lecture that speciation is when an organism turns into two different species, right? And that happens over a long period of time, okay? So we see down here, we've got a common ancestor. That's our ancestor. Here's a speciation event. One organism went this way, the other one went this way. Now there's another speciation event, and it branched into two new ones. Here's another speciation event, and we've got two new ones. And so over here, this is going to tell us that the bottom of that field goal post, if that's what you want to think of it as, is the farthest back in the past. And as we go up this line here, that's getting closer and closer to the present. So it goes from past to closer to the present. That's the way that we read that chart. All right, so that is it for today's. And then let me know if you have any questions about your assignment. You're going to create your own cladogram. And I miss you guys, and I hope you are having safe times at home.